Excellent. So in this video, we're going to look at power rule, how to take the derivative of x to a power, and do example 2. Parts all the way through F, A through F there. So power rule is one of everybody's favorite. The derivative of x to a power, right? Take the derivative of x to a power. It's just, oops, don't write in highlighter. It's just n times x to the n minus 1, right? N is your power, n is just a number, okay? That is so much easier than looking at rise over run as run goes to 0. The derivative of x to the 5th is just going to be 5x to the 4th. 5 minus 1 is 4. And done, right? If I told you that f of x is x to the 5th, then f prime of x is just 5x to the 4th. No more limit of f of x plus h minus f of x all over h as h goes to 0. Look how delightfully simple that rule was. All right, the derivative of x to the 3.5 power. That's just going to be 3.5 times x to the 3.5 minus 1, which is 2.5. And done. Right? Equivalently, if I gave you the function f of x is x to the 3.5 power, and asked you to go ahead and find the derivative, you bring that power down in front, x to the 1 less power. This was delightfully simple to do, but remember the power of this thing. This is a function. If I put in any x in the domain, what is it going to spit out? It's going to spit out the slope of the tangent line to y equals x to the 3.5 power at that x value. Super, super cool and delightful that it's this easy to do. All right. Negative exponents. The derivative of x to the minus 2 is just minus 2. X to the minus 2 minus 1 power is a minus 3. It's really, really common for people to accidentally say minus 1. Slow yourself down for a second. Negative 2 minus 1 is a minus 3. You know? Equivalently, I could have said, hey, here's your function. F of x is 1 over x squared. It's x to the minus 2. Go ahead, and in fact, I think I made you calculate this one from the definition somewhere in homework. Right? Now it's so, so delightful. The derivative is just minus 2x to the minus 3. This function tells me the slope of the tangent line at any point in the domain of this function. Woo! So, so cool. Now, a little bit of algebra review. We actually, to use power rule, we actually like having those negative exponents. We also like having fractional exponents. And so let's just, this is not a derivative rule, but let's just review negative exponents and fractional exponents. So any number, a to the minus r is 1 over a to the r, right? This is notation for the reciprocal of a times itself r times. Okay? And so in your algebra classes, you often were going in this direction. You were getting rid of the negative exponent. But in your calculus class, I want to write things with negative exponents so that I can use my power rule. And I just wrote A for any base, but you know what? I think I'm going to make them X's. Just because. All right? Your fractional exponents, the nth root of x to the m is also the nth root of x all to the m, which is x to the m over n. The root that you are taking is the denominator. And I'm just going to highlight that one, because if you get one right, you know you're going to get the other one right. The root that you are taking is the denominator. Okay? And we don't usually, for square roots, we don't usually bother writing the little 2 there. But here's a little example. How about the square root of x cubed? Oh, we don't usually write that little 2, but it's there. Square root of x cubed. This is x to the 3/2 power. The root that you are taking is the denominator of that fraction. Okay? So again, in your algebra classes, you really liked taking something from fractional exponents and writing it in the radical form. But in your calculus class, fractional exponents are your friend, just like negative exponents are your friend, because that way you can use power rule. No more rise over run as run goes to 0. Okay? So find f prime, find the derivative given that f of x is 1 over x cubed. So here I'm not doing any calculus. I'm going to write 1 over x cubed as x to the minus 3 power. And now I'm doing the calculus using power rule. The derivative is just going to be minus 3 times x to the minus 3 minus 1 power, which is to the minus 4 power. Yeah? Super awesome. This function, given any x in the domain, anything other than 0, this function is going to take in an x and spit out the slope of the tangent line to this function. Really, really delightful. Okay? Given f prime of, find f prime of x, given f of x is the 5th root of x squared. So no calculus here. I'm just going to rewrite f of x as x to the 2/5 power. The denominator is the root that I'm taking. And now I'm going to do f prime of x using power rule. Bringing that power down in front. 2/5 x to the 2, and maybe I don't want to do this in my head. 2/5 minus 1 power. 1 is 5/5. So just simplifying, 2/5 x to the 2/5 minus 5/5 is to the minus 3/5 power. And that's delightful. Done. If you want to clean up that negative exponent, you can say 2 all over 5 times x to the 3/5 power. If you want to rewrite that 3/5 power as a root, that'll be the 5th root of x cubed. That's all fine and dandy. I'm happy with either. Okay? What is the value of this function in green? Given any x in the domain, it'll spit out the slope of the tangent line to that function, the 5th root of x squared. Super, super cool. All right, so just to kind of make this real, I've decided to go ahead and graph that function. F of x is x to the 2/5 power. It's the 5th root of x squared. I'm going to put in my point of tangency, a comma f of a, and go ahead and let a be a slider so I can move this point around. Whee! All right, and we know that the equation of the tangent line using point slope form will be y minus a is equal to, y minus y1, y minus f of a is equal to the slope f prime of a times x minus a, right? And lo and behold, boom, do you see how the purple line is always tangent to the red curve? Let's see if the f prime that we found is in fact the derivative, is in fact giving me the slope of the tangent line at every point on that red curve. Y minus f of a, sorry I keep hitting z, is equal to f prime of a. So our derivative was 2/5 x to the minus 3/5 power. So at a, it's 2/5 a to the minus 3/5 power times x minus a. Woohoo! Let's zoom out a little bit. Look at how our derivative really is giving me the slope of the tangent line at every point on the red curve. The purple line and the black line are the same. Very, very cool. So the value of finding that derivative is now given any point on this curve. I can actually say what that instantaneous rate of change is there. I can say what the slope of that tangent line is there. And using power rule, we got to do this without doing rise over run as run goes to 0.